So good
Sure.
evening again. It's great to see you all here. It's Thursday evening. I hope you all have had a great day. And topic for today we're going to cover is about earth blocks, which is an affordable and a sustainable option for modern homes. How, where, why? For all that we have Sagar with us. But before moving on, let me tell you a little about Arkihive. So we are a platform to explore materials, to connect with professionals, and you can also discover your opportunities here. Apart from this, we do a lot of talk series on design and materials. Previously, we've covered topics like minimalism, interior lighting. We've also covered colors in interior design. And there are a lot of topics. You can follow us on YouTube for the same. You can watch all these videos that we do. We have our recorded videos there. So follow us there. We also have our Instagram platform. So do follow us. So here we are speakers for today. There is me and Shreya. We both are from the Arkihive team, and we have Sagar. Sagar Reddy is the founder of Earth Blocks India, and from a very young age, he is into this eco thing, eco sustainable. All of what I've read about him is about it, and more than me, you might know about him throughout the presentation. He's open to all your questions. He'll be there for you throughout the presentation. Also, at the end of the presentation, we will have the Q&A round separately, where you can actually talk to him and clear your queries. Let's understand what all we're going to cover before he takes over the presentation. I would like to give you all a brief review of what we're going to cover today. So, of course, sustainability and how this material for today, earth blocks, fit into this category. We'll be talking about that. We'll be deep diving into the types and understanding of this material. We'll be talking about composition, materials, manufacturing processes, their practical applications, advantages. Also, we'll look into the service part of it, of how practically executing these earth blocks, fitting in all the services work. And Sagar will also be running us through a few of his projects. And after this, we'll be open for the Q&A. So in between, in anywhere, if there is doubt, you just keep your questions in the chat and we will address all of that. I hope everybody is clear. Yes. So over to you, Sagar. You can just take on the presentation.
Sure. Thank you. All right. Thank you for the introduction. All right. So looking at the audience, what I'm going to do is I don't want to go too much in detail. I'll try and just tell you our inputs on what we feel about earth blocks, and then I'll try and keep as much time for Q&A. Try to answer your queries than me pushing what I have to give all of you. Okay, sir. Firstly, to start with, why we are a manufacturer. Okay, we've started this as an approach saying when we came across this idea, and probably when I was looking at building my own house, there weren't really alternates, and I'm talking about as recent as 6 years back. So when I went out looking for wall material, there were only two choices, either a concrete block or there was clay bricks or there was porotherm. So there were just three options. And none of it really made sense to me because throughout the construction phase, I saw the way people build. There isn't really a system that is actually followed. There is tremendous amount of wastage. We overdo the kind of materials that we use. We don't need to have such heavy columns. We don't need to have such thick roofs because we're not building commercial complexes. It's mostly houses. So we basically overdo everything just for a small house. So that's the idea where Earthblock started saying, this is not at all sustainable. There needs to be an alternative. And we went around, this company is set up by me and two other partners, both of them good friends of mine. So all of us got together saying, why isn't there anybody doing it? And then that's when the research started. And since there was nobody doing it, they said, okay, come on, let's get started. With the only objective saying, if we start tomorrow, there might be 10 people who copy us today. In a year's time, probably in the future, there'll be 100 more who will look at our success story and follow our way of doing things. And that way, we've given everybody a head start. So that's the actual intent that we had. And the way the book says sustainable construction, it's a practice of creating a healthy environment, and it needs to be on ecological practices. So here what I'm trying to refer to is just by adding or replacing earth blocks into the building does not make the entire system sustainable. Sustainability is a lot more than just the wall material. As architects, as contractors, you or whoever you are, you need to think differently. The wall material is probably about 20% or around 20% of the actual material that goes into a building. There is a lot more that is not actually sustainable, for which we don't have actual alternatives in terms of there is no replacement for cement as of now. We've tried every possible binder that has come out as of now, but it's not as easy or as affordable as cement is. So if there isn't a sustainable option, what is the way out? So our way of looking at sustainability is try using as little as possible, try using as less as you can. It can be on roofs, it can be pillars, it can be walls, wherever it is, try use less. So our way of looking at it is, for example, if if say for a general house, I'm just going through a context and then I'll actually get to the slides, Samruddhi. Yeah. So our way of looking at it is try use as little as possible. So there are alternates where you can use less when you make your roofs, when you make pillars. In the kind of bricks we make, we use a maximum of 9% cement. It's usually between 7 to 9%. So sustainability right now, the entire construction industry is not actually thinking of sustainability when it comes to carbon, when it comes to polluting. We are right now at the peak of the bell curve, and it's now slowly trying to trickle down because now everybody is finally conscious. People have realized that, if we don't do something about it, things are going to go bad. So that's why the world's going with, climate change and this summit and that summit, every country promising to do green climate. So we think this is one way that we are helping in the bigger aspects of, climate change. And more importantly, it needs to also be comfortable for the homeowner. For you to be staying in that house, you need to feel good, you need to feel healthy, you need to feel some difference by switching over to a sustainable resource. It shouldn't be more expensive on your pocket, trying to go eco. So that's what we've tried to address in our journey so far. Okay, now we'll go to actually what Earth Blocks is. Now, Earth Blocks is a sustainable material. How many of you have actually gone and, at least visited a sustainable house or actually seen one? I don't think you'll see much of it in a city, but if you go towards a rural side, go towards a village or a tier two, tier three city, the pass through villages, you will find lots and lots of houses. Our great grandfathers built houses of mud. Those houses still exist, and when people from those houses don't actually use an air conditioner, don't use a fan, but they're still comfortable, they feel cool, they're healthier because they use less and they've, in line with nature. So this is a very, very old system. We haven't in any way invented anything. We just remodeled the whole thing. I'll get to how we did that. So earth blocks as such is a sustainable material. Why? Because previously, before the industrial age, this was the only access they had, and they made best use of what was around. So why is it so great? It's very, very energy efficient. Energy efficient, why? Because it does thermal cooling. It's eco-friendly because you don't burn. Agriculture friendly, what we mean by this is when you use clay bricks, burnt bricks, you use a lot of clay from lakes and ponds. Now this is very, very fertile soil which ideally needs to go as fertilizer or soil enriching substance for farming, but instead that is taken out from the ponds and put in shape and burnt, so it goes back to the construction industry. So that's why, clay bricks, we don't like clay bricks for that reason, not because they burn it, but because it's nutrition for plants which is being burnt. Sustainable development, of course, and throughout the process of what we make with earth blocks, there's no gases because there's nothing so harmful that's put into it during the production. Same point again, river dredging soil is not used in producing CSCV, so it saves on the agricultural land. So what is so good with earth blocks or CSCV? We've got many different names. People refer to it in about 6, 7 versions. Soil blocks, eco bricks, compressed stabilized earth blocks, stabilized mud blocks. They're basically all the same. I mean, the whole process is you take the right mix of soil, put a little bit of stabilizer, put as much compression as you can, and you have a lovely brick which just needs to be cured with water to help the stabilizer get more strength. So the benefits are, it is fireproof, there's nothing to burn in it. Soundproof, why? Because it is not as hard as granite. It is not so it doesn't, sound doesn't bounce off it. It gets to absorb a little bit. Bug proof, if it's compressed well enough, bugs can't just dig into it and make holes in it. These are breathable. Water as vapor can go in and come out, but so because of that, again, that's what helps in your thermal comfort. It's mold proof, it's non-toxic, it's low cost. Again, it's low cost subject to how you utilize it. It can't be low cost because sometimes we get customers who call from Delhi and say, can you send bricks from Bangalore to Delhi? So that doesn't become low cost. Low cost is when it's used around where it's manufactured. Ultra low maintenance. Why? Because you don't need to paint, you don't need to plaster, and even if it gets dirty, it's a natural finish. It just blends with the whole thing. It's not like a clean white wall where one dirt doesn't show up as much. Structurally sound, the bricks that we make have compressive strengths of above 10 MPa. Some bricks have 10 to 15 MPa, some bricks have 15 to 30 MPa. All this is because of the size and the shape that we make with the blocks. It's earthquake resistant. It's earthquake resistant because we've given some options where you can put in rebar. So by putting rebar, you get a lot of lateral strength, and that's what gives you earthquake resistance. The After the recent Nepal earthquake, uh, the entire system there of reconstruction is with CSCV and interlocking, and with rebar in it. So you can understand how it is on a hilly region. It's difficult to take material up, and they just take cement there, use the soil that's available, and putting a little bit of rebar, it becomes earthquake resistant, and the product is definitely durable. We'll go to the next slide. Okay, what is CSCB? CSCB is known as pressed earth brick or a compressed solid brick. It's a building material made of damp soil and compressed at high pressure. I'll take you through how we make these blocks. We'll go to the next slide. Okay, types of CSCB. Okay, the what we mean by types of CSCB is mostly the way it looks and the way it functions, but the manufacturing process is the same irrespective of what it is. So a solid block is as good as a solid block. It doesn't have anything else. So these are like your usual masonry system where you have to put mortar on every course, and it's built one after the other, one on top of another. So this is a normal masonry kind of requirement. Cement mortar will be required between the courses. So this, again, the specs are almost the same for all of it. The size is a little different. Here, if you notice, the compressive strength of these blocks that we make is about 16 MPa. So that's the minimum that we get. Water absorption is a very key point here. 8%. So this is more than what the IS standard is asking for. The IS standard for India says, the water absorption can be anywhere between 15 to 20%. But with our manufacturing system, we've got it below 8%. The bulk density is 1.9 to 2, 2000 kgs per meter cube. So that's how much we've compressed the brick. So that's where you get the strength and the rigidity, and the compressive strength comes with the density that we achieved. Next slide, please. Okay, this is one different version of the brick. This is a solid interlock. Basically, it has a male and a female. Now, the male and the female are on two sides, the top and bottom, and the front and the left and right. So the facade is what you would see, and otherwise, all four sides lock with each other. So again, this is a dry interlock system. Very, very little cement is used as slurry just to be put on top because we've kind of put in about a 3 mm gap between the male and female. So that's where you put very little cement mortar and slurry, and it's just stacked one on top of the other. So that's how easy it is to construct. Again, this kind of a brick, we've got 16 MPa. IS standard asks only for 3.5 MPa for clay bricks. That is probably how much it goes to. 3.5 MPa is what IS standard says is enough to build a load-bearing structure. We've overachieved the compressive strength. Again, why we've overachieved most of this is, people have to get convinced. People need to know that, yes, it's an alternate viable solution. Same specs for all the bricks that we make. It's just the shape that's different. We go to the next slide, please, where I'll show you the hollow interlock. Now, this is probably about 95% of the blocks that we make. So this design is what has been very, very good for us and successful. The other two designs were not really something that we worked on. That was because of a need base. People wanted those other designs. But this is the design that we worked on, and we kind of perfected the design. The reason why this is so good is because we've thought through a lot of things in terms of putting rebar, resizing it, reshaping it, reshaping it, helping with speeding up the construction system. Time is saved, labor is saved, the amount of cement that you use is saved, and it gives you lateral strength. Again, the same specs. The holes that you see there is because once you stack the bricks, you would pour cement slurry into these holes. And when you pour cement slurry, it goes in locks, top, bottom, left, right. So all the four sides get locked after you place the bricks. So you build about 4 to 5 courses and then you pour slurry. The slurry goes and packs into all the voids. And we also recommend putting rebar every meter. So by just one every meter, not for every hole. And those holes can also be used for your electrical conduiting. So while you build the wall itself, you get your conduit. So there's less time wasted in, cutting, chipping, and replastering. Again, the same specifications that we have for all the blocks. See, in this block, we have a little lesser in terms of strength, but that would definitely increase. Uh, that would definitely increase once you put the cement slurry. And the bigger benefit in this kind of a block is the kind of lateral strength that you would achieve in this is far, far higher than any other system, even compared to a concrete block, because of the rebar that's put in. We also have a small, another version of this hollow interlock, which is called the U block. So it's in the shape of a U. It's a kind of a U cavity on top. So that is what is used as lintel beams on top of doors and windows. So it becomes like a concealed beam. So you've got rods going, rebar going horizontal and vertical. So you get a complete mesh kind of construction. So just with 6 inch being the width, 6 inch walls gives you enough and more strength. And this size 6 inch is actually beneficial for city dwellers because you get more carpet area, because you only need to make 6 inch walls. We don't have different size bricks for inner walls or outer walls. We use the same size block for the complete house construction. Okay.
Yeah, so Sagar, we had some questions from the pre-registered members, and I would like you to address these questions. One of it is, what is the scope of earth blocks as a building material? Can it be used for all types and scale of projects to achieve sustainability?
Okay, scope of earth blocks as a building material. You see, we've been in production for the last 5 years. We've completed close to 400 projects in and around Bangalore. We've luckily been in a situation wherein we always have a waiting period for the blocks, so that clearly explains, there is enough need for it, enough demand for it, as long as the quality is there. Can it be used for all types and scale? We've got a huge gallery pictures on our website. There we talk about it being used for weekend homes, for farmhouses, for residential houses, for commercial complexes, which are G+4, residential houses G+3. We have an agricultural university near Bangalore built with this. We have a brewery, an industrial brewery that's built with this. In Anantapur, we also have an apartment complex being built with this, 400 flats, 9 floors, 5 towers. So that's the scale in which this material is getting used. So it's all. I mean, there isn't really anything wrong with it. Just that people don't know about it. For us, from the beginning, we've always had a pull strategy and never a push strategy. So I can't just go to a layman and force it down his throat and say you have to use earth blocks. It's always been a pull strategy where conscious people come to us saying, yes, we've either experienced it, we've seen this, we like it, we want it, or I'm really an eco kind of a guy and I want to be sustainable. So these are the three kind of people that we get. So they are the biggest guys who do our marketing. We barely spend a rupee on marketing. We've actually been hiding in a corner, but still people find us and come to us.
So I think there are no shortcomings, but it's just the acceptance of this material as a whole for all kinds of projects.
There isn't any shortcomings, but the reason why these shortcomings are there is, people who have been doing it are doing it with half knowledge. They would just see somebody doing it and they're like, it's
Right.
so easy, let me go and try it. So that's probably not the right way to do it. Probably the kind of guidance they're getting is not right. I know a lot of college kids who go to Auroville and learn this stuff, but they're not the people who go back and actually sit and make these blocks. They may be the
Correct.
guys designing with it, but making it is a different thing. It's like, everybody can find rice, chicken, and stuff like that, but making a good biryani, it's kind of understanding how things work.
Correct.
So
Correct.
that's where the problem is, or that's what we've seen.
All right. Okay. Yes, we can move to the next slide.
Okay, so the material and composition, what goes into making these blocks? Now, firstly, soil. Soil, when we say soil, is again, you can't use every kind of soil. It's a big disappointment for most people up north, because we get a lot of calls from Delhi, UP, mostly in the northern part of India. The biggest problem there is you get black cotton soil. Now, black cotton soil is very, very heavy with clay. So the reason why clay bricks are burnt is because once you burn, clay loses its properties of expansion and contraction when water, affects it. So that's the reason why you burn it. So what kind of soil you get down south and most part of middle, you get alluvial soil, red soil. The kind of soil is, we are also very picky in the kind of soil we take. You can't just take any soil. Every soil doesn't work. The soil needs to have a certain amount of composition, which I'll take you through. Of course, there's cement. The only other alternative to cement right now is lime. But again, there isn't a guaranteed quality of lime that is available. You're not sure if you're getting chalk powder or lime most of the time. And again, if I need lime in Bangalore, it has to come from Rajasthan or Jaipur. So it's, again, doesn't make sense for us to transport things just for this. Water, of course, and waters, again, not too much, very little, and admixtures. We've done extensive research on admixtures and we've tried out every possible combination of which works best. And we've identified a few that work for us. For different bricks, we use different admixtures as and when the need comes to. Next slide. I'll take you in detail. Yeah. So what should be there in soil? Or what is the brick made of? So the maximum of 9% is what we would recommend. More than 9% doesn't make sense, because more than that, your brick will stop breathing. If it doesn't breathe, you don't get that kind of thermal comfort. And again, the soil needs to have this kind of a ratio, this kind of a proportion. That's when it functions the way it's supposed to function. So cement is a maximum of 9%. Again, that can be altered based on what you're making. The bigger it is, you can reduce the cement. The smaller it is, like we make the hollow interlock, we have to put 8 to 9% because we need it much stronger. The solid block can be made with 5%. The soil, in the soil, we need 50 to 60% as sand. So this is like your concrete. Sand is like our aggregate. So we need sand to be there, and the more coarser, the better. Silt is again between 50 to 20%. Clay is again 50 to 20%. Clay cannot exceed more than 20% because we don't burn these bricks. And if I use soil which has more than 20%, and then it'll eventually lead to cracking. So we don't want that cracking. So we play with the soil. We check the soil before we get it to our factory. Again, we don't just go and dig soil because we need it. We take waste out of construction projects wherever they're digging a basement out. That's the kind of soil we procure. So the soil that we source is not what we buy or what we demand for. It is something that is being taken out of a project, and that's what we use. And the water we use again is very, very little. It's just to achieve the optimum moisture content. It's barely considered a big need. So probably to make 500 kgs of mix for soil and cement, we would probably use about 25-30 liters and not more than that. Why testing is very important is if you don't get the composition right, you will fail in making a good brick. There are quite a few methods. Everybody uses a different system. The wash test, pen test, shine test, these you'll have to go into detail for you to understand how each test is done. Basically, what each test would do to, what it would explain to you is Does it have clay? Is there enough silt? Is there enough sand? So all these tests, one way or the other, will give you an indication of what the composition of the soil is. So that's as much I want to talk about testing soil, because it's too much in detail to go into testing of soil. Or the easiest thing for anybody to do, if you want to do a project, send it to a lab and ask them to find out what is the composition of soil. Next slide, please. Okay, we go to the manufacturing process on how CSCV blocks are made. So firstly, we process the dirt mix. Again, this is where most people fail. Processing is very, very important. What we do in our factory, the first thing we do is we crush the soil. It goes through a crusher and it's powdered. You know, whatever there is, it's powdered, it's sieved, and then we keep it as a dry stack. Now, this is a very, very important process, which I have seen 99% of the people do not follow. And this is where they fail. Because when you get soil the way it is, you have a lot of lumps. If it's not crushed, the cement cannot just go into a lump of soil. It needs to be crushed, it needs to be dry. So the process that we do is we first take the soil, we do a dry mix, we add a little bit of sand if required, if we find that the soil is not as coarse as required, or if the clay is a little more, then we add some bit of manufactured sand, a dry mix, then a little bit of water, and compression. Compression is the key. When we make our bricks, we put a minimum of at least close to 20 tons of pressure. Now that's the amount of pressure that we're subjecting the brick during the manufacturing process itself. And cement will eventually get strength. Molding process, again, mold is subject to the requirement. You can make these blocks in probably any size and shape that you want. You've probably seen it in the previous slide. It is just a convenience. Molding is just for convenience. You can make it to whatever size, whatever shape, as long as it's within a few structural parameters. So once the molding is done, stacking is done. Stacking is in palletizing, and then curing. Curing, it has to be cured at least for 14-15 days before you can ship it out. That again depends on how you make it, uh, what you put in it, how good the soil is. Ideally, you need 21 days for the cement to get its full strength. And then you have a quality building material. I'll probably take you through a video, a short video in the next slide. So this is how we make blocks at our factory. It's a 30-second clip. It's not long. So that's the dry soil going into a pan mixer. Cement is mixed, soil is mixed, sand is mixed. We put water, admixture goes into the water. It's pressed, and there comes out your brick. That's the first brick that you saw was U brick, and this is the brick. This is how it's stacked first. For the first 3-4 days, we stack it indoors, keeping it covered. Was it only catchy for me, or did the video run smooth? Okay, again, another video to show you how these hollow interlock bricks are set up at site. You can play the video. Pretty simple. So this is where we try to show you how simple it is, how easy it is, how quick it is. You can see there is rebar every meter.
There is some time lag with the videos. I'm dropping both the links of both the videos in the chat, so you guys can have a look at it later as well.
So that's how the dry interlock is being done. So they would probably do about 4 courses. Once 4 courses are done, cement is mixed in a slurry kind of consistency, cement, sand, and a little bit of soil if required. And it's just poured into those voids with the rebar. Now, once you get to a certain height, even the electrical conduits will go into the, those holes in them. I think that's good enough. You can go to the next slide. All these videos are there for anybody to learn on our website. Okay. I guess this is a question.
Yes. So I'm dropping the links of the both the videos in the chat for you guys to access. Next question is also from one of our pre-registered members. This person is from Delhi, as you had mentioned, I guess, some time back, Sagar. So, as
Hmm.
an architect from northern part of India, how can I get the clients that appreciate use of sustainable materials like mud? From where people aren't educated enough, they hardly approach any architect or designer that have right knowledge of design. So basically, how to convince the clients about going for this technology.
Um, See, again, convincing is not an easy task because people always have a predetermined, information on their head. It's not easy for people to change just like that. At least now it seems a little easier. The millennials, probably are willing to experiment. Luckily, we've had that advantage in Bangalore where, at least we believe people in Bangalore are quick to change and adapt. Again, like I mentioned earlier, it always has to be a pull strategy. Somebody should be willing, to build their house with this. Again, it's very difficult for you to push this product on anybody because it's not something that you would buy and sell or let go. It's not a car, it's a house, so you'll want it for the rest of your life. So you need to be really, really convinced. Or okay, let me put it this way: when people come to me and ask me, why should I build my house with earth blocks? Firstly, I never ever speak to them about it being a cost saving feature because that is there, but I don't want to highlight and feature that. What I would actually talk about is, the thermal cooling that it has. It will give you 4 degrees cooler temperatures. It breathes. So if there is humidity, it'll absorb the humidity. It makes the air a little fresher. Or even simpler way of convincing people, have you tried water from an earthen pot vis-a-vis water from a refrigerator? So when you taste both of it, when you drink water from these two sources, you know how differently it feels. So that's what earth blocks does to a house. It gives you a natural way of cooling. It makes you feel good because of the calmness. It gives you soundproofing. It gives you better air. It gives you better temperature. And I also happened to meet a person who is well versed with Reiki. He wanted to build his house with this. So he tried. I mean, I'm not saying it's scientific, it's non-scientific, but I have to believe what I saw. So he came and tried his plum. He has a brass plum kind of a thing. He put it on a concrete block. It spun anti-clockwise. He tried this on a fly ash brick. It didn't move at all. And when he tried the same thing on an earth block, it had positive energy. It went clockwise. I don't know how many of you know this. It can even work with a Rudraksh on you. If you put a Rudraksh on your head, it'll turn clockwise, anti-clockwise. If you're happy, it goes clockwise. You're angry, it goes anti-clockwise. So there is some kind of energy. Why is there energy? Is because firstly, it's as good as natural earth. There isn't too much which spoils in terms of chemicals, or there is cement, but besides that, it's all good. So there is a feel good factor. Luckily for us, it's always been word of mouth. That's where most of our references come in. Somebody goes into a house that's built with an earth block, we're like, it's nice. It's just the whole experience of being there is nice. And then there is a sustainability part and eco-friendliness and all that. So the approach cannot really be a hard push. So ideally, how I would suggest you to be is, be available, put your information all over the place. If somebody searches for something like this in Delhi, you should be the first one to, come up. Do as much work as you can. Be noticed wherever. Search, blogs, I know, catalogs, wherever it is. You need to be available because there are enough number of people who want to build with this. Probably you're not getting a direct connect with them. I'm sure there are a lot of organizations coming up with sustainability. In Delhi, also, I've heard of a few companies who are doing this. So I guess you just need to be present. It's not easy to get started from day one. It's taken us a 6-year journey to get to where we are. It's always a slow start, but things are definitely changing. And I'm sure after COVID, people have actually realized, this is a better way to live. A lot of people have changed their approach in life, and we've got a huge increase in the number of inquiries after COVID.
Yes, I'm sure. Yeah, so I hope we've answered your question, whoever has asked this. Okay, let's move on to the next slide. And also, I would like to remind you guys, during the presentation, you guys have any questions, please put up in the chat so we make a list of it and we address it. Yeah, Sagar, we can go ahead.
Yeah. Applications and advantages. Next slide. Okay, since earth bricks are breathable, they create ideal indoor climate. Again, who figured this out? Probably rats, rabbits. They're the ones who dig burrows, go into the earth. Why? Because, that's the best place to be. It's natural cooling, it feels good. There's enough moisture when required, there's enough temperature difference when required. Environmentally sound. Uh, these structures can use about 20 to 30% less energy, again, because of the passive cooling, heating and cooling than concrete block or wood frame structures. Wood is mostly an insulator. It doesn't let temperature from outside come in, but it won't, add to a temperature difference as such. Concrete block, again, I will talk about it in the next slide. Non-toxic, most houses that we build don't get plastered, don't get painted. So no painting, no plastering is a big benefit, when it comes to toxicity. You don't really know what goes into paints. Uh, Long lasting earth blocks have been around for thousands of years. Earth blocks will last for centuries. Just to cite an example, the Great Wall of China, parts of it, the walls that cross mountains were made of stones, and all the walls that were on the plains were made from rammed earth. So this is kind of learning on being sustainable. You would just build with what is available around you. I mean, for me, I sometimes refuse to understand, why would people get granite or, Italian marble from Italy? I mean, that's crazy. That's in no way sustainable. But if you look at great examples like this, you need to build something. You find things as close to what's available to you. Basically, what I'm trying to say is transport it as little as possible. Let it not cross seas and mountains. It should be things that are around. That's where you are actually sustainable. Diversity in design, again, achieve various wall thicknesses, molds and mold possibilities are used as possible. See, when it comes to sustainability, what I'm talking about is, see, we make these CSCV blocks. There is another system called rammed earth, which is again the similar process, the similar style. Almost all is the same thing, but instead of it being manufactured piece by piece, it's made as a whole wall. So thickness, the thicker the walls, the better the thermal comfort. Earth blocks and services. So this is an example of how the hollow interlock bricks, the electrical conduits, just to show you how it looks. The mason, while he's making the wall itself, will cut the brick using an angle grinder, and he would place the electrical box and get the electrical pipe. So in this case, the electrician comes much later. This job is done by the mason itself. And when it comes to plumbing, ideally, we would request all plumbing to be done on the exterior of the building. And when it comes to the interiors, we what we recommend is first plaster it, then put your plumbing, do some bit of waterproofing, and then any which way it's going to be tiled. So bathroom tiling is completely the old-fashioned way. The electrical conduits literally go into the wall, and you don't waste time at all after the wall is built. Okay, thermal performance. The principle is as simple as, water being in an earthen pot. That is the oldest refrigerator that people had to cool water. It basically works where during the night, uh, the coolness around and the moisture around is absorbed by the brick, and when the sun comes out, and probably the sun is out, the maximum heat is generated between 3 and 4. That's when all the moisture is getting out of the brick, so moisture is coming out as vapor. So that is where condensation would happen, and because of this principle, you get cooling during summers, and you get warm cooling during winters. This happens 24 by 7, 365 days a year without a single unit of electricity consumed. So this is just what soil does. And then again, I've just given you a reference to porotherm blocks and concrete blocks. See, what concrete blocks do is, throughout the day, sun's energy, the temperature that falls on it, it holds on to that energy. And even during the night, during the evening, it is letting go of that heat that it's already absorbed because it has no other way to do it. It's got dry heat inside and it's letting go of dry heat. So when you put in an air conditioner, the air conditioner will at least take 2 to 3 hours to first cool the walls, and that's when you would actually start to feel some comfort. And the second example is a Porothon block. Porothon block is an excellent alternative because it is lightweight, but Porothon block is mostly used in the colder climates. It's mostly a German system, not really too much of a Indian thing. How that helps is it has air voids and it works like a thermos, a flask. It has an inner wall, an outer wall, and it got air in between, trapped air in between. So air inside becomes an insulator. So this helps wherein the heat from outside will not come in, or the coolness from inside will not go out. So it's like a flask. The only difference with earth blocks and why we push earth blocks and we love earth blocks so much is because it has a system of breathing in and out, which gives you the kind of comfort that I'm talking about. Go to the next slide. Okay, what kind of finishings that we do to our bricks? I think there's a video that's playing which shows you a system of our finishing. That's a hydrophobic coating that we've done on the blocks. So what hydrophobic coating does is it kind of breaks the water molecule's surface area. So it doesn't let the water molecule break. So the bigger benefit here is it's literally like a Teflon coat. If water is put on it, it will just slip away. But water as vapor can still go in and come out. So the breathability is not stopped, but water cannot literally go in as a droplet. What at least I believe is the biggest enemy to any building is water and heat. Water and heat. So if you can manage water and heat, your building will last for years and years and years. So this is our way of coming out with a solution. We would never ever recommend an earth block or a rammed earth wall or anything to do with earth. It should not be painted. Even if it's painted, it should not be painted with enamel, varnish, and things like that. It's like literally putting you know a plastic bag on your face and you won't be able to breathe. So that is something that is not at all recommended for earth structures. It has to breathe, and the only alternate that we can think of, and the only thing that we suggest, is a hydrophobic coating and not a waterproofing system. It's a hydrophobic coating. Please understand the difference. uh, Pointing is a simple system you could see on the top picture. Pointing is where, once the bricks are stacked, there might be some minute gaps. So soil cement is mixed in a basic ratio of 1:4, and, it's just filled into those bevel edges. And of course, cement or lime-based paints are good enough. Lime would actually add to the whole feeling. Lime, as you know, would just keep getting whiter as it ages. So lime also will help in cooling the building on the inside. Next slide, please. With energy effectiveness, this is again, here we're only talking about the amount of energy the block consumes during the manufacturing process. This is giving you a comparison between country fired bricks and compressed stabilized earth blocks. So here, if you're using a 5% ratio of cement, you're probably doing about 1,100 megajoules per meter cube, and country fired bricks is about 4,500. So literally, less than 25%, or rather, CSCVs are 4 times lesser polluting than country fired bricks. So this is again only during the manufacturing process. We're not talking about the energy efficiency of these being a wall system where it's going to save you energy throughout the life of the building. This is only the manufacturing cost of carbon. We go to the next slide, please. So again, this is a big question, how cost effective it is. I will tell you how it is cost effective, and then I'll tell you why you actually don't get the benefit of it. So with the kind of system that we've devised, the cost of wall construction is reduced. Why? Because you don't use plaster, you don't use that much cement, that much labor. There's no finishing on the wall. There's only a pointing cost. You would reduce labor requirement because of the speed of construction. You're at least 20 to 30% faster, even while building the blocks, or while finishing the blocks, since there's no electrical conduits to be cut, chipped, and finished. reduce usage of sand and cement. How we reduce usage of sand and cement? The bricks that we make are very, very good when it comes to geometry. We always talk millimeters. The height difference that we guarantee to our customers is, it will not exceed more than 1 mm. It will be less than an mm. So that's the kind of accuracy that we get in our bricks. So when you have good geometry, you get good plumb. It's straight. And, once you build your wall and you cast your roof, even the roof is straight. So you don't again put extra sand, just to get a level for your tile. So that's a complete waste. So by using geometry efficiently, if you get the first row right, you will save a lot of material throughout the building because of leveling, because of the plumb, the straight, the square. So that's where you would reduce usage of sand and cement, reduce future maintenance costs. Why? Because you don't repeatedly go on and paint, because paint needs to be touched up quite frequently. But here, the hydrophobic coating that we spoke about has a life of at least 8 to 10 years, and it's a very, very simple way to reapply it. Again, it's an enzyme, not a chemical. It's diluted in water and sprayed on the wall. That's how simple it is. It increases the speed of construction, and wherever speed increases, cost comes down. It's eco-friendly, soil is sustainable, eco-friendly, and we don't burn them. Unskilled manpower can construct using the system. As I said, we've come close to 400 projects, and we don't have a construction team. We basically help them with a construction manual, and we help with some YouTube videos to our customers. And with that, there are a lot of people who are skilled enough to build with this already. I mean, we've got customers who are outside Bangalore where we have no intervention whatsoever. It's as simple as kids playing with Lego blocks. If you can build a house with Lego blocks, you can build a house with earth blocks. Is earthquake resistant? Here, the way we look at it, if you're doing, say, just a G+1, we would tell all our customers don't even build pillars, because by putting rebar, you're distributing the weight of the roof on the walls and not being a point load on the pillars. And once this wall is built and the roof is cast, the weight of the roof also gives more rigidity and structural strength to the walls. Passive cooling, cost effectiveness comes from there also, cooler interiors. The sizes, the reason why we stuck to a size of 300 mm is because it matches with tile sizes that you get. 300 mm, 600 mm, 900 mm. So the whole point of doing these sizes was, we would, again, what we tell architects is whatever you do, just make sure all openings and all sizes are in multiples of 150 mm, which is half the size of a block. So you don't even waste a brick. You either use a full brick or a half brick. We don't want you to use a 3/4 or a 1/3. No. If you're opening for doors, you put it as, multiples of 3 bricks. If you're making rooms, just multiples of 150. That way you save on a lot more. We don't want to waste tiles. So tiles would fit in exactly, windows would fit in exactly, doors would fit in exactly. With the kind of bricks that we give, you can build a house without using a tape measure because it's already there. If you have to tell your mason, I need a plug point, at this place, you would say fifth course, third brick, and that's about it. You don't literally need a tape to do it. So with all this in place, it's a zero wasted system. When you build with this kind of system, there's not much that you would throw out during the construction. There's not much that you would actually waste. So it's a very, very efficient way of doing it. So all this put together is what gives you the cost effectiveness. And as I mentioned earlier, why most customers don't get this cost effectiveness is because, it's very difficult for you as an individual. I mean, not all of you, but others as customers. Nobody wants to go and do this all by themselves. You're just giving it to a contractor. So the contractor is usually billing on square feet. So there's no way that, maybe there is a contractor who's good enough to share his savings with the customer, but usually people get stuck with a square feet cost. So the cost during construction is not really translated to the customer, but the long-term effects of maintenance, your cooling, the feel-good factor, all this is definitely there with the customer. So that's why when we get customers, we know who's a customer who can build on their own and who can't. So we don't really speak about a price advantage right in the beginning. Only if they insist, we would say, you save, but this is how you save. Next slide, please. Okay, the limitations. Why are there problems? Why is it not, as famous or as popular as it should be? The limitations, because not many people go through a structured way of understanding how to do it. Proper soil identification is the most important one, because if you take the wrong soil, you can't obviously make a good quality CSCB. I mean, you can possibly take any soil and make these blocks, but it needs to be altered. There's a lot of things that you can experiment on and, try. There is slag, industrial slag that can be mixed, granite powder. There are a lot of things that can be mixed to, make it efficient for CSCV. But this is where people lack the understanding, unawareness of the need to manage resources. Again, they're not really sure what they're doing, because I've seen, CSCB being made at site, manually. There's nothing wrong in it being done manually, but what I've noticed is they would mix 50% M sand, 10 to 15% cement, and they're actually making, something very close to a concrete block. It doesn't anywhere come close to, a CSCB standard. So that's the awareness issue. Untrained teams, produce bad quality bricks. Again, what we would insist on doing is we always want to use a hydraulic machine to put the right amount of pressure, because we believe if the right amount of pressure is not put, the brick is not strong enough, the compression is not good, the water absorption would be too much. Again, it's a similar example to saying, how strong is a chain? It's as strong as its weakest link. So even if there's one brick which is not good and it's, say, right at the bottom, it kind of, spoils the entire structure of the building. Overstabilization through fear of ignorance and impure implying outrageous. Okay, again, as I said, 15%, 20% cement, which is not really necessary. It's just the right amount of pressure that's required, the amount of compression that's required. If you achieve a density of anything close to 1.8 to 2, then it's a very good brick. Understabilization results in low quality products. Of course, if there's not enough binder, it's not going to hold for long. Bad quality or unadapted production equipment. Yeah. So this is very, very simple to understand. We've kind of, gone over all of these. We've understood this. Again, luckily for us, we've had the right set of hands in Earth Blocks who have expertise to, guide us through all this. So we've overcome all these limitations, and that's why we stick to a machine manufactured way of making these CSCB blocks, and a scientific way of, testing the soil, making sure it's the right composition, right proposition, and the kind of admixtures and enzymes that we add into our blocks. Next slide, please.
So yeah, one more question that we can address is how to preserve the natural made structures, that is the earth block structures, in long run without adding any extra material or doing any extra arrangement for it.
The biggest enemy to earth block structures is water. Again, water doesn't mean see, the bricks are stabilized. We've made a brick in factory about 5 years back, and we've put it underwater just to prove to anybody who comes there, saying, it doesn't disintegrate. Once there's enough binder that is there, it will not disintegrate. But having said that, any brick, any construction system for that matter, has, a problem of capillary action. If you've not done your DPC right, if you don't if you have water that's somehow seeping into the bottom, bricks, any bricks, even concrete bricks, clay bricks, or CSCB, all of these have a capillary action that would suck water from the bottom and, go through the wall, and the dampness will spread from within. So if you have issues like this, is where, your structure kind of goes bad. So I again believe water is the biggest enemy for any structure, any man-made structure, cement-based structure. So if you can, in the designing phase, in your construction phase, try your best to, make sure water is not affecting your walls. If you do your bathrooms, you have to do proper waterproofing. Waterproofing is what is very, very important. And again, there are old systems of doing waterproofing. Now there are tremendous options and fail-proof options that are available to do waterproofing. For example, if you're doing, say, your foundation, your basements, there is a crystalline cement. If you mix a little bit of that in the cement, even in the future, if there's a crack, it goes and fills the crack and doesn't let water come in. And these are not at all expensive. We have a lot of, again, when you build is where you have to take care of this. Once if it's built wrong, you can't hold the structure. It needs to be built right. A hydrophobic coating is a very good example where it keeps the structure safe from water from very, very long time. Again, water as vapor goes in and out, but water as a droplet doesn't come in. There is a lot of plasticizers which nobody's even aware of. Plasticizer is so economical. It's like less than about 80 rupees a liter, and you would add about 50 ml per bag of cement. Now, just by using plasticizer, the kind of density you get, the kind of workability that you get in cement is tremendous in concrete, in helping in waterproofing. Unfortunately, you know, it's like there is no restrictions for anybody to build. So anybody who wants to build is going ahead and building it. You either pass civil or fail civil, or you know a friend who's a civil guy becomes a contractor. So that's where the problem is. So if you use the right materials, again, I'm not recommending anything which is expensive. It is just understanding the fundamentals of what breaks a structure down. It's heat and water. If you can kind of control that during your construction phase, it will really last a long time. Next question. Okay, just some examples of the houses that we built. This was a ground plus three, four-floored building. This is a brewery. It's a industrial building. Here, the walls are actually 15 degrees slanting. It's not straight walls. They're bent 15 degrees. And here also, the walls were 7 meters at 2-3 places here, 7 meters. So that's almost 21 feet. This was again possible only because we have those concealed U beams where rebar goes into the walls. Because of rebar is where they've been able to achieve a 15-degree slant. The tilt is 15 degrees. This is a brewery project, and here you would see, this is, I mean, it's a very good example here. The roof is not really plastered, the rough finish. This is a practical example of using very less to achieve, the same kind of output. Next picture. Again, a similar building. This is a raw brick that's not even. I mean, this is not even finished. And I would love to be in a house like this. Just gives you a very nice rustic feel. After pointing, you would get a little more smoother finish, but otherwise, this is the look. Again, industrial buildings. These are industrial buildings. Next slide, please. These are residential buildings. Now here you see how they've used our bricks in different patterns. Again, this is not something that we recommend. I mean, we didn't suggest this to anybody. They just experimented like kids building with Lego blocks. So here what they've done is, instead of using metal, instead of painting, putting grill and shutters, just by using these blocks, they get their privacy, they get their circulation, they get air. I mean, it's just left to the architect, builder to use it the way they want it. This is residential houses, G+1, G+2, farmhouses. Next slide, please. Again, this is back to the same G+3 house. See, there's no paint for the rest of your life, so that clearly indicates the amount of, I mean, that is in a way being sustainable, because if a building has to be painted every 5 years or 6 years or 8 years, at least you do more often on the outside and less on the interior. But you are completely avoiding paint for the life of the building. So that in itself is being sustainable to a small extent or a large extent. Next slide, please. Again, the bigger advantage of using these bricks as arches, very little amount of cement, metal, beams, all that is actually avoided by just making arches with blocks. That's again a very sustainable way of doing it. Again, I've been repeating this quite a few times. The lesser you use to build, the better it is. Now, this is an example of me using three different styles of construction. Now, what you see, the wall system is our bricks. The one in the center is a rammed earth wall. So that's again the same soil that we used, stabilized with cement and rammed manually using rammers and just putting shutters. shuttering in the side. So that is an example of rammed earth wall. And what you see on the left and right is something called poured earth. So what we did with this poured earth is throughout the construction of this entire building, G+4, all the waste that came out of the building, where broken chips, bits, whatever it was, we kept it all aside. And towards the end of the project, we added a little more soil, mixed a little bit of cement, some admixtures. We put some shuttering, and all that waste went back into making the compound wall. So there was literally nothing that was thrown out of the building. So complete efficiency. And here you see columns are not painted. For the life of the building, there is no paint in this house. Probably the only thing that was painted is the roof, just to get good lighting. Otherwise, there's practically no paint, hardly any paint in this building, and for the life of the building. Next slide, please.
Okay. So with
Oh,
this,
that's the end of it.
yeah, that was so insightful, Sagar. You
Okay.
you have been really like very informative, especially me, because when I was listening to you for the first time, I was like really intrigued by whatever you were saying.
Uh-huh.
Okay, so now moving ahead, we will go ahead with the Q and A's.
Okay.
So we will be taking up the questions that's already here.
Hmm.
The first one is, does the hydrophobic coating have to be applied annually?
No, no. See, there are different manufacturers to this. Uh, Again, at different price points. There are expensive ones where the manufacturer claims it'll last anywhere between 15 to 20 years. And there are, again, it's just a price point. There are things which last longer. There are some brands which make good products. Um, what we recommend to customers is a mid-range kind of a product which gives you a life of anywhere between 8 to 10 years. So the reapplication is only after 8 years, and the actual cost of the material is about 2 rupees per square feet. There's a different cost of application, labor and all that, but the cost of material per square feet is only 2 rupees, so it's not even a big cost to compared to paint.
Okay. Moving ahead to the next questions. Walls are great solution, but what are the solution for horizontal surfaces, that is slabs and multi-storage structures?
See, multi-storage structures, again, as I said in the beginning, we haven't actually found an alternate for cement. But there are alternates for slabs when it is a residential project. There is, again, there are a lot of people doing a lot of research on this. People use, what do they call? Empty cavity, tiles that are put, pots that are put on top. Basically, that is to reduce the weight of the roof. There are precast beams that you get, which are put on the roofs, and then a very thin roof that is made. See, the issue again, like I'm saying, is we need these structural engineers to actually define, the safety that is required. We build residential houses like they are commercial complexes. A residential house will probably not carry more than 2 tons of weight per floor, but we build it so strong that you can actually put 20, 30, 50 tons. So we're basically overdoing the strength aspect when it comes to residential houses, at least in the independent residential houses. I won't comment too much about multi-story structures, but you have to actually speak to structural engineers. Why do we need 2 feet by 10-inch pillars for a residential house? I mean, basically, the structural engineer has to really, think through what kind of a zone this is in terms of earthquake zone. Is it really necessary to put this kind of fat pillars? Why can't you reduce? See, again, like I said, by getting good geometry, you don't put dead weight on the building. Basically, that's what we're trying to do. To be sustainable, use less, reduce the amount of dead weight. For multi-storage structure, I am sorry, I really don't have too much of a solution for this. There are other alternates for earth-based structures where you can do without a slab. These are called earth bag construction, where you just use earth bags and go round, 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 and you get the shape of a dome, where a roof is not required. But these are practical only for rural, not really for city kind of an environment. There are options, but not really for multi-story structures.
I think
Okay.
Ranjit is trying to say something. He's also putting in some insight where he's saying jack
Okay,
arch
sorry.
roofs. Yeah.
Jack Arch Roof. Sorry, Ranjit is my partner in Earth Blocks. He's a technical geek. He's
Oh,
an
okay.
IIT guy, so he's giving me those suggestions saying Jack Arch Roof, filler blocks.
Yeah.
Yeah, clay pots, filler blocks. So those are. Thanks, Ranjit.
Okay.
Okay. Considering that the thing that you said, right, that we don't, for as of now, we don't have any solutions that we've come up for multi-storage structures. So, can it be counted as a limitation? Uh,
No, no. What I was referring to is the slab, the roof slabs.
mhm.
I cited an example where we are actually running a project in Anantapur for a builder who is doing, 9 floors, 400 apartments using CSCV blocks.
Mhm.
My only reference to not being used for multi-storage is when he referred to, sustainable materials for slabs. As
Okay.
wall material, you can use this. There is no restriction.
Okay.
But as a slab, I don't have too much of option.
Okay.
Again, there are some research that's been done in Oroville where they do, I think it's called GFRC ferrocement. They make curved, semicircular, cylindrical shapes which are precast on the floor and just lifted and put on place. These work very good. They've done about 3 to 4 floors doing the system that uses very, very, very little steel and cement, and it gives you excellent ventilation. And it's kind of using arches, Houdini blocks and slabs. So those are the options. I mean, there are options available, but it's been proven. It's not that it's an experimental phase.
Mhm.
It's a proven system of doing it. I'm not sure multi-story if you're talking 9 plus 10 floors, but yeah, you can definitely. I've seen buildings in about 4 floors where all the systems been used, and it's a excellent way to use it.
Okay. So moving ahead, I would also request the participants, if you guys have any doubts or any queries, you can put up the your questions here, and we'll be answering them. Till then, we'll move ahead with the questions we have already. So we have this question: if we use bamboo instead of rebar, will it
Hmm.
need rebar?
Rebar, yes.
Rebar. Oh, rebar. Okay, sorry. My bad. If we use bamboo instead of rebar, will it change anything in the construction process?
Uh, I mean, bamboo is again an excellent alternate, but again, I mean, there's nothing wrong in using bamboo. That's a whole different system altogether. It's been used from a lot. I mean, it's been used from ages. People are still using it, but again, information is the problem. Not too many people know how to use it. The only limitation that I know of bamboo is, it's firstly very, very expensive as of now. It's not available everywhere. Probably bamboo is used only towards where it's available, like towards the northeast, where it's actually available. And there's nothing wrong in using bamboo. Bamboo is as strong as steel when you compare the weight. Bamboo is an excellent material to use, but again, we don't have enough of it as of now.
Okay.
It's just
Um,
accessibility. I can't go to the store tomorrow and say I need 100 kilos of bamboo.
yeah, that's true. Yeah, we have another question. When it comes to curved walls for earth blocks, are there any limitations or care that is to be taken care of? Anything?
Um, See, I won't be an expert to talk about the other systems of Earth. There are at least 10 different ways of using Earth, like your bamboo, your straw, your rice husk. The reason why we didn't dwell enough into all those is because we see as a sustainability factor, it is not as practical. Now, what we are trying to do is CACB, we're in the city, we're trying to get more people to use this. All other systems are mostly, experimental. It has a different kind of a niche. Somebody who really wants to build that way can build. But those systems cannot really become mainstream construction systems. So that is why uh, we've done no research on it, though I know all those are good because our grandfathers have done using that system. But I mean, I really don't have the time to do anything in those lines because that's just, something that you would do as, if you have a farm, you would do it as a hobby, you would just do it because you want to do it. It would not fly mainstream. It won't help, changing people towards sustainability. It's very, very difficult. It's difficult to convince people on CSCV. How would it be possible to convince somebody using, straw and rice husk and bamboo? It's not, it's very difficult, not possible as far as I see it.
Okay. We've got more questions actually. So there is this question: can earth blocks be used for good sound insulation?
Yes, of course, because it breathes. Again, if you understand how sound works, if it like if you go to the theater, you have a lot of acoustical treatment. What does acoustical treatment do? You have something, some kind of a material which can absorb the sound. So that's the same thing that earth blocks do. If you compare, earth bricks, and if you say granite is an extremely hard, more denser surface where sound as a sound wave, would bounce out of a granite stone, but in an earth block it would get absorbed. It would work as a sound insulator because it has that breathability. It can't, sound cannot be just stopped. It's very difficult to do that. But if it's an absorbing material, it's like a sponge which can absorb moisture, which can absorb sound. So that's where you get the calmness in an earth block building. Sound insulation actually depends on the thickness of the wall. Sound has different wavelengths, and bass has I don't know if I'm going too technical. The wavelength, the lower the wavelength, the frequency is too fat, so you will actually need more than a meter of thick walls to stop sound from going in and out. So that's a different science altogether. But the thicker the walls, the better it is for thermal, for sound, for moisture, for everything. It does help doing some amount of sound absorption. Next
Okay.
question.
Yeah. So the next question is: can you please elaborate on interior plumbing while using CSEB?
Interior plumbing while using CSCV. So what we recommend is, you get your plumbing first. The way plumbing has to be done is you have to finish putting all the plumbing, then put your tank on top. If you're even doing some pressure, put some pressure. Let the pipes just be there for a week. So, once you're sure there is no leaks, that is when you should plaster. There is no different way of doing it. You can do it the same old way that's it's been done from day one. We don't actually want you to put the pipes into the bricks, because in case there is a leak, in case there is a failure, if not today, tomorrow, there's no way to access it. So always try and keep plumbing accessible, at least till it reaches your bathrooms. Keep it on the outside, and once it comes in, we we first recommend a good amount of waterproofing to be done, and then plaster, and then put your plumbing. We don't recommend the pipes to be put into the bricks. Only electrical conduits are recommended to be put into the bricks. Plumbing, as far as possible, first plaster, then do the plumbing. Again, not because of any other reason, but how much ever effort and time you take, there will be somewhere that water will go. Water is a very difficult thing to stop with gravity.
Okay. Uh, so moving ahead to the next question. So do we need any separate kind of foundation for this technique?
Foundation is purely dependent on your site conditions. If you have hard soil, your structural engineer would tell you what kind of foundation to use. The bricks should not determine what the foundation should be. It is either, in what earthquake zone are you in? What is the actual weight of the completed structure? So your structural engineer would kind of define, what's the weight of the building, and depending on the weight of the building, he's going to suggest you the kind of foundation depending on the soil condition. So the foundation has got nothing to do with the walls or the roof. It's to do with the soil and the weight of the building.
I think
Also, in case later you guys have any questions, you can also mail us. Okay, we address questions even later post the presentation. So please send us your questions. Thank you, Sagar. It was great. It was great to have you here. We look forward to collaborate more often. Thank you so much.
Sure.
Thank you, guys.
Thank
Thank
you.
you, everyone.
Thank you, everyone.